Okay, Rocketeers, let me share with you what your project looks like and how you're going to go about completing it. So you will receive this as your primary source of links and information to the e-module. And each one of these links you can click on in order to download them. You'll have to force copy them. And what that means is when you click on them, it will require you to make a copy. And if I did this correctly, when I click on these directions here, which are just another copy of what you're seeing on the screen, um, it should force you to make a copy. And when they do, it becomes yours to make changes to. Now, this document, you're not going to make any changes to. This is just for your information. And it has the items that you need to be able to link to the rest of the project that you're going to um, complete. So that was that. Let me start with probably the most important document to appreciate the understanding is the activity. So when you click on this document, again, it's going to force you to make a copy. And in it, you can document all of the information that you find from this project, which is you're going to build a rocket. There are video links from YouTube. One basically goes, this middle one, the Science Buddies video, will tell you the science behind rockets in general. And I won't click on that one, but this one um, will show you, well, actually, no, I'm sorry. I think that first one is what does that. The second one will go through what a bottle rocket design looks like. Now, this is a design that you shouldn't hear the audio for this, um, but it goes through a situation where you're going to pump air into a bottle rocket. You may not have an apparatus to do this. You would need a tire pump that has a bicycle pump that has an ability for you to have a gauge to know how much pressure you're putting in it, and not everybody will have that. And then this aquapod apparatus is its own type of thing that you could get to do your rocket, and that would be fun. But not a lot of people have these hanging around the house. So another possible opportunity for you to get is to use to do a vinegar and bicarbonate um, combination, which will also help you launch your rocket. And this is an example of one that you could use, something similar to this, or you have the idea that you have a bottle full of vinegar. It says malt vinegar. It could be any vinegar. And in this stocking, there's bicarbonate or baking soda is another way of saying it. And you're not going to mix them together. It is going to be come through a little bit, but there's going to be a reaction between these two items, and that reaction is going to cause the pressure that you see happening, and you'll see. Okay, and I don't want to spoil it for you now, but you're going to be able to put it in here and suspend it from the opening, but not combine them until you turn the bottle over. Okay, so I'm going to leave you in suspense and not let you see it until you look at it for yourself. Um, and in this document, what you're going to do is, so there's a lot of student reading here, a lot of background science information. And this is primarily designed for you to develop the information you need to draw on a quadratic equation in math and determine heights and determine the length that your rocket stays in the air and the height that you can reach. And you want to be able for it to reach its highest potential um, height in the air. And this goes through a few ideas of what it's supposed to look like. A little drawing here that makes it look like it goes through Newton's laws to give you a scientific idea of why this is all happening. If you decide to do this with a group, which is possible, you can do it with a group of two other members and break up the roles. If you decide to do it less than three rather, total, let me know and we can correct that right there. And we can talk about how to break up these roles, but I'm sure you could figure that out. But if not, let's have a conversation about how you would do that. Then you're going to collect data for all of your trials. The first is you're going to draw a preliminary finding on what you think is going to happen when assuming that you're going to do the vinegar bottle rocket, what that's going to look like, what you expect to happen, and then list all the available materials that you're going to use for propulsion. If you decide that there are other materials, um, let's again talk about that. Have a video or have some background knowledge or data or information that you found to support what your design is going to be and how you're going to create the propulsion for your rocket. This phase two, after you have created the design and you have anticipated what's going to happen, you're going to draw your design here. When you consider your design, you're going to consider things like the nose cone, whether or not you're going to use wings on them, or any other items that could help with propulsion and direction of your rocket. You're going to try this 3 times. You're going to do it first, and then you're going to come to some conclusions. We'll talk about that in a moment. And then you're going to develop 2 more designs from which you have already evaluated your first. Here are some roles when you're considering who's going to do what with the filming and the timing of the rocket can be done together, or you can do the timing of the rocket um, from the film because you can see a time lapse on your recording. So make sure that you record all of your trials with the rocket propulsion in the air so that you can see the arc of what the graph would look like for a quadratic equation, and then you could also help determine what the height is from that point. You're going to record all your information here. You're going to put the time in flight. You're going to include the description of how much vinegar, what fins you used, what the nose cone was, if there was one, how pointed it was. And in your video, hopefully before it starts, you'll put a link to your video here so that we can look at it, each one of your trials. Again, after the first one, you're going to, after you do all of them, you're going to decide what you think is best based on the information that you have so far, and you'll be able to change that when you do your reflection. So here's a lot of where you're going to do your design information, document your design information, and some of your preliminary findings. Then you're going to analyze your analysis after you've done your design, your first design. You're going to use this equation that we've already given you, the formula for the maximum height of your rocket, how long it took to reach the maximum height, and understanding what the variables mean. And they all listed all here. You're going to record your rocket trials. You're going to, in step 3 of this phase, you're going to use the formula to determine the velocity. And then you're going to find what the greatest height was for each one of your trials. And you can use this formula right here to help determine what the maximum height was as well. So trial 1, we're going to ask you to show your work to know that you understand how to use the quadratic equation, how to substitute the variables correctly. And then from that information, you're going to fill in the rest of the tables and the other forms of the equation, the quadratic equation. You can and should also insert a graph of your 3 flights from Desmos, and you can do it all on one if you want, where it shows the arc of each one of your flights after you've created your equation for each one of them. And then it's going to ask you what the domain represents and what the vertex represents. So here's where you're going to put all of your mathematical analysis. So from your first, when you do your designs, when you draw your designs, and if you have a problem drawing designs or linking anything, to let me know. But if you can at least put a link in for your designs, if you decide to use another resource to do it, that's fine, as long as I can be able to access it. And then you're going to make sure you complete your reflection. And your reflection is going to basically have you look at all the information you completed in the other 2 documents and determine which, and justify in your response with the math and the science what you think, what rocket flew the highest and why you think it did so, and which one lasted the longest. And then you're going to also just your overall, what you feel like your overall best representation of your rocket was, and you're going to document that here. And again, you want to try to justify that with as much of the information that you've already completed in the other documents as possible. And finally, you have here the lesson plan available to you, which along with this direction module tells you the standards that we're covering, which are in science, math, engineering, and in technology as well as some of the practice standards in those content areas. I hope you have a lot of fun with it. It seems like a lot, but it is going to be a lot of fun, and it will hopefully help you understand how to mix together all of the content that you're learning in one cohesive STEM activity and lesson. And you should try to ask as many questions and answer as many questions as best you think you can from the activity here. And I do hope you have a lot of fun with it.